In the era of cold weapons, the quality and manufacturing techniques of weapons were directly related to the combat effectiveness of the military. What was the quality of weapons in the Song Dynasty, and what level did they reach at that time? During the Tang Dynasty, the 100-fold steel-making technique pushed the craftsmanship of cold weapons to its peak. However, in the Song Dynasty, this technique was improved by the crucible steel-making method. What was the reason for this? Today, let's deeply understand the scientific logic behind the crucible steel-making method from the unique perspective of metallographic analysis. Here is a fragment of a knife from the Song Dynasty. Next, I will share with you in detail the specific process of metallographic sample preparation. First, use the TRULE CT-50 manual metallographic cutting machine for cutting and sampling. The selected cutting disc is the 6D alumina grinding wheel, and the cutting part is the cross-section of the knife. Then, fix the sample with a stainless steel metal clamp. And then use the TRULE MT1H hot pressing embedding machine to embed the sample. Using a quantitative feeder can avoid dust generation during feeding, and there is no need to worry about the operator inhaling dust. The embedding material used is the EP20 to 37 edge retaining hot embedding material, which ensures a closer combination between the sample and the embedding material. In the grinding process, use the TRULE Alpha 208 double-disc manual grinding and polishing machine, and grind with silicon carbide metallographic sandpaper in sequence with particle sizes of P400, P800, P1200, and P2500 subsequently. For polishing, use the YES polishing cloth with a 3M polycrystalline diamond polishing solution. After completing the polishing, corrode the surface of the sample with a nitric acid alcohol solution. Finally, observe its microstructure using the TRULE Minesto Ta80 metallographic microscope. The 100-fold steel-making process refined the grains through folding and forging, improving the material's uniformity. But it was difficult to solve the brittleness problem of high-carbon steel. The crucible steel-making method cleverly used pig iron high carbon as a carburizing agent. During the high-temperature fusion process, carbon elements diffused into wrought iron, thus forming a gradient material. In this way, it not only avoided the brittleness of overall high-carbon steel, but also reduced the softness and bluntness of wrought iron. Overall, the weapons of the Song Dynasty far exceeded those of the Tang Dynasty in terms of production, efficiency and cost control. By combining the crucible steel-making method with the sandwich structure, the equipment level of ordinary soldiers in the Song Dynasty reached a new historical high. The core of the improvement of weapons in the Song Dynasty was that, instead of overly pursuing the overall uniformity of materials, it achieved a balance between performance and cost through local strengthening and material compounding. Although the weapons of the Song Dynasty were inferior to the 100-fold steel of the Tang Dynasty in terms of material purity and corrosion resistance, they were more in line with the needs of large-scale wars and can be regarded as the forerunner of standardized mass production in the era of cold weapons. This transformation from the ultimate craftsmanship of the Tang Dynasty to the pragmatism of the Song Dynasty vividly demonstrates the differences in social structure and military needs between the Tang and Song dynasties. In the polished state, gray strip-shaped sulfide inclusions can be found in the matrix, and there are intergranular cracks at the blade edge. After etching with a 4% nitric acid alcohol solution, the matrix is ferrite, and the grain size is uneven. The sulfides are distributed in discontinuous thin strips or spindle-shaped aggregations along the forging and processing direction of the knife. Trojan. Discover the truth of material.